Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from autumn 2022. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 23 to 26, which account for 19 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 23A. Find the next term of the following Fibonacci type sequence. So the way a Fibonacci sequence is, you add the previous two terms to find the next term. So 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34. So now we're doing 21 plus 34. So the next term is 55. Part B, find the nth term of the following sequence. Okay, so we need to see what the sequence is going up or down in. Now the sequence is going up, it's an increasing sequence. To get from 4 to 9 we add 5, 9 to 14 we add 5, 14 to 19 we add 5, and 19 to 24 we add 5. It's important you check that it's increasing or decreasing by the same amount for it to be a linear sequence. Otherwise we do something entirely different. So it's going up by 5 every time, so we can start our nth term rule by 5n. Now we need to compare this 5 to the first number in the sequence. What do we need to do to 5 to get to 4? Well, we need to subtract 1. So we're going to write subtract 1 on the end there. So our nth term rule is 5n subtract 1. Question 24. A glass of water is placed on a small table and the table stands on horizontal ground. Part A. The total mass of the table and the glass of water is 9.6 kilograms. We're given the ratios: the mass of the table to the mass of the glass of water is 11 to 1, and the mass of the empty glass to the mass of the water is 3.5. What is the mass of the empty glass? Okay, so we're working with two different ratios here. So the thing to note first is that the mass of the table and the glass of water has a total of 9.6, which relates to this ratio here, mass of table and mass of water. So we're going to go table to water, and it's 11 to 1. The total is 9.6. Well, 11 plus 1 is 12. So we're doing 9.6 divided by 12. Okay, I'm going to start by writing that as a fraction, but then I'm going to multiply top and bottom by 10 because I don't want that decimal number there. And then what I'm going to do is I'm going to simplify this fraction as far as I can. Now 9 plus 6 is 15, that's in the 3 times tables. 1 plus 2 is 3, that's in the 3 times tables. So 96, we're going to start by dividing by 3, is 32. 120 divided by 3 is 40. These are both even numbers, so we're going to divide by 2. So that's 16 over 20. Okay, I want to know what this is as decimal, so I'm going to make it over 100, guys. So I'm going to times by 5. 20 times 5 is 100. 16 times 5 is 80. So that's 0.8. So each part of this ratio is worth 0.8. So 1 times 0.8 is 0.8. And 11 times 0.8 must be the 9.6, take away the 0.8, which is 8.8. Okay, so we now have the mass of the glass of water. So that's when it's full. Okay, so now we're going to use this mass of the glass of water with the mass of the empty glass and the mass of water. So we're moving to our new ratio, guys. So we're doing the empty glass to the water. Okay, and they are in the ratio 3 to 5. Well, we know that the mass of the glass of water is 0.8, but we don't know what the mass of the empty glass and the mass of water are separately. But if that's 0.8, then that's the total for this ratio. So let's add this ratio together. 3 plus 5 equals 8. So that total for the glass of water is 0.8 divided by 8, which is 0.1. So we want the mass of the empty glass, so we're going to times that by 0.1. 3 times 0.1 is 0.3. So the mass of the empty glass, which is what we're looking for, is 0.3, and we've been working in kilograms, so let's leave it like that, 0.3 kilograms. Okay, part B. One second. So we're using the formula for pressure, so force divided by area. The base of the table has an area of 1,600 centimetres squared. Some books are also placed on the table. The books, the glass of water and the table exert a pressure of 0.1 newtons per centimetre on the ground. So that's the books, the water and the table. Calculate the force exerted on the ground by the books, glass of water and table. Assume that the whole of the base of the table is in contact with the ground. Okay, so pressure equals force divided by area. So we're given the area as 1,600. We're trying to work out the force and we're given the pressure of 0.1. Okay, so the force is equal to 1,600 times by 0.1. Okay, so what we're going to do, let's times that by 10. So we're doing 1,600 times by 1, which is 1,600, but we times by 10, so we'll need to reverse that. We're going to divide by 10, so it's 160 newtons, but you can just put 160 there, guys, you would be absolutely fine. Part C, in fact, the assumption made in part B is incorrect. Okay, so this assumption here, part of the base of the table is not in contact with the ground. Describe how this changes your answer to part B. Okay, so if the whole of the base of the table is in contact with the ground, we're dealing with this whole area. Okay, but if the whole of the base of the table isn't in contact with the ground, the area is going to be less. So if the area is going to be less, then the force would be less too. So you can just write that. The force would be less. Question 25. So we've got sale 40% off, a ring, and its reduced price is £1,008. So in a sale, jewellery is reduced in price by 40%. The price of the ring is reduced to £1,008 in the sale. What was the price of the ring before the sale? So we're trying to find the original value. So with 40% off, it costs £1,800. Okay, so the original price would be 100%. So I'm going to use a proportion table here with some other working out, just to organise my thoughts. Okay, so we're going to deal with the price and the percentage. So the reduced price is £1,008 with 40% off. So that 40% is the original 100%, take away 40%. So we're working with 60%. So 60% is £1,008. Okay, so I'm going to divide by, divide by 6, yeah. I'm going to make 10%. So let's divide by 6. So I'm scaling down to 10%. So I'm going to divide this by 6. So 1,008 divided by 6. So 6, 12, 18, 24, 30, 36, 42. So 6's into 10 is 1, remainder 4. 6's into 40, 1, 2, 3, 4, 5, 6. Remainder 4. 6 is into 48. I haven't gone far enough. 42, 48. 1, 2, 3, 4, 5, 6, 7, 8. No remainder, so that is £168. That's 10%. We want the original price, so we want 100%. So now we're scaling up. To get from 10% to 100%, we're going to times by 10. Do the same on the other side. So that would be £1,680. So that is our price of the ring originally before the reduction in the sale. Question 26. Expand and simplify, and then we've got double brackets here. So it's up to you how you do this. I'm going to use a grid, guys, because it helps me organise my thoughts a little bit. and then I don't miss anything out. So this bracket here, I'm going to put 3x and minus 4. 3x minus 4. This bracket here, it's 5x and plus 7. Notice that the signs are going with them, and we're treating this as a multiplication grid. So in this square here, we're going to do 3x times 5x. Well, 3 times 5 is 15, and x times x would give me x squared. In this box here, we're doing 3x times positive 7. Well, it's a positive times a positive. So we're going to get a positive. 3 times 7 is 21. So that's 21x. This box here, negative 4 times 5x. A positive times a negative times a positive gives me a negative. 4 times 5 is 20. So that's 20x. And then in this box, negative 4 times positive 7. Negative times a positive gives me a negative. 4 times 7 is 28. So now we're going to simplify this. We've got 15x squared. We combine the diagonals. So we've got negative 20x plus 21x. So that's plus 1x and then minus 28 on the end. Part B, factorise each of the following. So we're going to do this first one. So when we factorise, we're pulling out the highest common factor of each term, and then we're putting that on the outside of the bracket. So I'm going to split these terms down. 2x squared y is 2 times x times x times y. Okay. 12x squared y is x times y, but I'm going to split that 12 into 2 times, and it's 2 times 6, because I want to pull out common factors, so it made sense for me to split 12 into 2 times 6, so we've got a matching factor of 2. So we're going to factorise, so it means we're putting in one bracket here, okay, one bracket, and we're going to pull out what they have the same, so we can take a 2, an x and a y. That's why I lined them up the way that I did as well. So we can have 2xy on the outside, so that's those dealt with. And then on the inside, in place of these terms goes what's left. So instead of 2x squared y, we're going to have x, and it's a plus. And then instead of 12x squared y, we're going to have 6 times y, which is 6y. Part 2. So we are factorising x squared minus 64. This is the difference of 2 squares. So we're going to have 2 brackets for this, guys. 2 brackets. The reason why we have 2 brackets is we have a squared term. To get that square, x squared, we need x times x. But we also have a constant number term. To get that constant number term, we need 2 numbers to multiply together. Now, difference of 2 squares. The squares is our hint. So 64 is a square number. Square root of 64 is 8. So we need minus 8 and positive 8. So that when we expand that bracket, the x term that would be in the middle, like we got up here, disappears, and we're just left with x squared and 64.